I'd like to officially welcome everybody to the September 22 Novice meeting of the Houston Astronomical Society. So our presenter tonight is somebody who you're familiar with if you've been on some of these presentations before. If not, our main speaker is Debbie Moran, who is our Novice Chairperson and does a lot with the club. Debbie has had a lifelong interest in astronomy since her childhood in Midland, Texas, where the scenery is the sky. She's been a longtime member of the Houston Astronomical Society and has served in a number of capacities here. Like I said earlier, she's currently our Novice Chair in charge of programs for new members. She also participates in outreach programs and is a volunteer telescope operator at the George Observatory in Brazos Bend State Park. She is the 2017 recipient of the International Dark Sky Association's Hoag-Robinson Award for education of government officials about outdoor lighting issues. In 2010, her Woodside neighborhood became the first one within Houston city limits allowed to install low-glare, fully shielded decorative streetlights. For the past 4 years, she's presented concerns about the choice of high-glare wide LED streetlights in Houston to city officials in hopes that the Houston area will someday join other communities in moving to warm or soft white to amber LEDs, which are recommended by the American Medical Association for the reduced glare and reduced disruption of day-night circadian function. And Debbie, I think you're starting to finally get some holes poked in the armor there and maybe hopefully making some progress in that regard. But without further ado, I'd like to pass the presentation over to Debbie Moran, and we'll listen to her presentation about observing Saturn tonight.
So hi, everybody. Yeah, Joe's going to stop sharing. So I'm Debbie Moran, and I've been a member of this Astronomical Society for a long time. I may be one of the few who joined before I first saw Saturn. We get a lot of members on their first view of Saturn, but I hadn't had a telescope before I joined, so I didn't see Saturn until after becoming a member of the Houston Astronomical Society. So this is one of our favorite objects. Some of you may think this talk is mistimed. I will explain why I'm doing it now instead of last month. We're actually slightly past opposition, which is when Saturn is the largest apparition of the sky, and I will explain why I like to talk about it sometimes a couple weeks later. I did at least mention it was happening, so it wouldn't take you guys by surprise if my last novice talk, but there's a good reason to talk about it even more now. So I'm going to go ahead and share my screen and hope this works out okay. Find my talk.
Yeah, Debbie, I'll just.
And I do see them. Yes, let me see if I can hide them.
Yeah, we don't see that there. And I was just going to reiterate that there's a chat function down below. And I see some people are using it already. Remember, just ask your questions there, and we'll get to those at the end of the presentation. So, Debbie, I'm sorry, you were asking a question.
Okay, so I'm back. Joe, before you go off, can you tell me whether I did succeed? At least from my point of view, I got rid of the Zoom controls.
Yep, everything looks good over here. No gray boxes or anything else.
Okay, terrific. Okay, well, it's about that time of year again when Saturn comes back in its closest approach to us. We're actually a couple weeks past that. But one thing I love about Saturn is that each year that it comes back, and it comes back mostly because we go around the sun a lot faster. So it comes back about every 378 days when we are the closest to Saturn that we're going to be for that year, because basically we're going a lot faster than Saturn. So we catch up to it. It's only moved a little bit farther the next year. So it's only a little bit. It only takes 378 days, not 365 for us to come closest to it again. And that happened on August 14th. But every time it comes around, Saturn is not like Jupiter. We aren't always looking at its equator. It changes its tilt of its rings to us, and we get to see a little bit differently every time it's the largest it's going to be in our telescopes. So I want to start out with a really wonderful image by Bill Flanagan, one of our really terrific planet imagers. And notice the date on this. This is June 11th, 2016, and see how open the rings are. That is not the case right now, and I'll explain a little bit more about why that is. So first of all, let's talk about why Saturn is named Saturn. So Saturn is the Roman equivalent god to Cronus, or actually a Titan, the father of the gods, And Titan was the god of agriculture, wealth, and time. And probably we think maybe the time part came in because of the 5 naked eye planets. that the ancients could see, Saturn would have been the one taking the slowpoke, the one taking the longest to move across the sky. So Saturn is the second largest planet if you look only at the sphere itself. It's actually the largest if you include how much sky it traverses with its rings. And this is just a good sort of to scale photo of what the relative size of all the planets. So it's one of the gas giants, which are in the outer solar system, which are mostly atmosphere, have very little core, as opposed to the rocky planets, which are Mercury, Venus, Earth, and Mars in the inner part of the solar system. And some people think maybe these gas giants are almost failed second stars. We know there's a lot of double star systems out there. They are mostly hydrogen and helium in their atmospheres. And if Jupiter, for instance, were 20 times larger, it would have become a second star. So this is, again, Saturn in context compared to the sun. And as you can see, the rocky planets next to the sun practically disappear. So if we were to include Saturn's rings to give you an idea of how big it is, you could almost walk across the rings if they were solid from the Earth to the moon. So they are getting close to the distance from the Earth to the moon, 384 kilometers, about 239,000 miles across. So Saturn is also the only planet that could float. It's about 30% less dense than water. So although it's very, very large, it's 9.5 times as wide as the Earth, its gravity is actually about the same as ours because it's a lot less dense. So the stuff of it isn't much different from Earth. The only problem is that we can't find an ocean that large. It would be physically impossible. So here are some just basic facts about Saturn. Its orbit is a little bit over 29 years to go once around the sun. Its day is a lot faster than Earth's at 10 hours and 14 minutes. It's about 9.5 times as far away from the sun as the Earth. And it's about almost twice as far away from the sun as Jupiter is, which is 5 times as far as we are, or about 890,704,128 miles. And that seems like an awfully exact number, but I'm assuming that's an exact average. So Saturn was at opposition on August 14th, 2022. And that would be when it was at our closest. But I'll show you in a couple of slides where it is in the sky and why I sometimes like to observe Saturn a couple weeks to a month afterwards. So Saturn's axis tilt is not too different from ours. It's 27 degrees. So Saturn has seasons, just like the Earth has. Its atmosphere is mostly hydrogen and helium, but the yellow color we see is due to ammonia crystals high in the upper atmosphere. And its gravity is very close to ours, 1.064 Gs. So if Earth is 1 G, that's almost the same as Earth's gravity. You would feel about the same hovering over Saturn. So what is Saturn made out of? Well, it has a very small rocky and metal core. After that is probably metallic hydrogen, then liquid hydrogen and helium. Then you get to an atmosphere of mostly hydrogen and helium. There's some ammonia, methane. There's some liquid ammonia farther down, then the crystalline ammonia farther up in the atmosphere. But largely, it's almost like a star. It's 96% hydrogen and 3% helium. So it's really made out of leftover star stuff. So we have a little graphic there of the gravity. On the left, it has this wonderful ring system, the only one that's as magnificent. We know now there's some sort of much smaller, thinner ring systems around a couple of the other planets. But this is the one that's really spectacular, probably because of a moon that never formed or was broken up. It has one of the largest moons, the second largest moon in the solar system, Titan, and the only one with an atmosphere. And I have to update this talk every time. So last time I gave this talk, I said it had 62 moons. Now it's up to 83 moons, 53 of them named, and countless little moonlets, which we still don't know how many there are. So it's a superior planet, meaning that it is farther from the sun than we are. And so here are the positions that a superior planet can be in relative to the Earth. And right now we are at opposition, and you can see why when a planet is at opposition, this is not to scale for Saturn, but why it is by necessity, just geometrically, the closest it's going to be to us is when the sun is opposite us from that planet in its orbit. It's also the closest to us. There's something called Western Quadrature and Eastern Quadrature, which is when it might be the highest in the sky. And then there's conjunction, which is when it's exactly opposite us from the sun. You cannot see it at all because it's up in the daytime. And I forgot to turn off my phone. I'm going to turn this off. Let me turn off the ringer. Just give me a second. Whoops, sorry. Forget it. I hope it doesn't ring. I'm too flustered to turn off my ringer. But anyway, let's go ahead. So just want to show you that opposition is when the planet is opposite the Earth from the sun. So here's Saturn again, gets you a general idea again, not to scale. Saturn's 9 times as far from the sun as the Earth is, but you can see the difference in distance. So 1.3 billion kilometers from us when it's at opposition as opposed to 1.5 billion kilometers. So Saturn's already pretty far away from us. It's not very large in an image in our telescopes. So seeing planets like Saturn and Mars, which is also not very large, at opposition is a lot more bang for your buck than waiting for it to be quite a bit farther away from Earth. Now, if you notice in this image, when Saturn is at opposition, it's also directly overhead at about midnight. And with daylight saving time, it's more like directly overhead at 1 a.m. What that means is that at sunset, Saturn is lower in the sky and just rising when it's at opposition. It's highest in the sky in the middle of the night, and then it's setting at dawn. So it's up all night. But planets require what we call good seeing to see. So to see well, you don't want them to be shimmering through a lot of atmosphere, like a penny shimmers in a swimming pool underneath the waves. So part of the factors for that is weather. So Houston actually has great planet viewing weather when we have this really very still, hot, humid air. Temperature inversions are great because there's not a lot of motion in the air. And you don't want to look at it right after cold front passage because there's a lot of turbulence in the air. But you also don't want to look at it through an enormous amount of atmosphere. So there's far more atmosphere when you're looking at the horizon than there is overhead. So why are we talking about Saturn after opposition? Well, this is last month's early evening sky map from skymaps.com for August 2022. And you can see when it got dark at about 9 p.m., it was pretty low in the sky, still rising in the east. And this is September's early evening map. And now it's already a good part of the way high in the sky during sunset or when it gets dark around 8, 9 or so. So this is such a wonderful thing to show to the children and to do outreach with. And so really, we have a lot of people say, well, they want to have their star party around opposition, but I'm always recommending wait a month or two after opposition so that when it first gets dark, Saturn is still relatively large in the sky. It's still relatively close to us, but now in the early part of the evening, when children are up and your outreach audience is up, and maybe when you're up, if you are not a hardened astronomer and looking all the time at midnight, this is really the best time, the best combination of time of night and being less atmosphere to look through, and also having a relatively large image. So it's a great time to plan star parties and to show kids Saturn would be in the next month or two. So right now it's in the constellation Capricornus, which is just beside the teapot of Sagittarius. And this shows its path. We're also right now in retrograde motion. So in January, it started over here, proceeded to May 2021, then it kind of came backwards, June, July. Then we get into 2022, and we start going backwards, and then eventually we're going to go forward again into 2023. So what's happening is that as we are in opposition, the Earth is catching up to Saturn and passing it up. And this is a nice graphic of how that works as the Earth catches up. This is with Mars. And it shows Mars relative to the Earth, and then the apparent motion of Mars in the sky. as we pass it up. So we're doing the same thing with Saturn. We're passing it up. Saturn's going backwards right now. After we finish passing it up, we'll start moving in concert, and Saturn will follow the normal path in the sky. One more time. So the other thing about Saturn is as it orbits the sun, it has this 27-degree tilt. And as the Earth comes close to Saturn, whether it's in 2009, it's on this side of the sun, or 2003, it's on this side of the sun, or somewhere in between, its tilt appears different to us depending on where it is in its orbit and where we are in opposition. So I'm going to start out with Sonny Manley's pictures that go back to 2018. You can see how we already saw 2016 where the rings were extremely open. You can see how they are closing. And now we just got some new pictures from member Andres Salaveria, which start in 2020, 2021, and he just took this picture in 2022. He says all of these are in August. So they're very close to opposition, if not exactly at opposition. And we can expect those rings to continue to close over time until 2025. So the rings open and close on a 28-year cycle. It's one of the things that makes Saturn a lot of fun to watch. So they spend 13 years opening and closing on one side of the equator, and then 15 years opening and closing on the north side of the equator. And I remember when the rings disappeared. So there is, when they get very, very edge on, get to the point where they look like just a thin pencil, and then there's actually a week where you cannot see the rings at all, and then a little pencil appears. That was great to watch. Unfortunately, I've been waiting and waiting for the next time that happens. But in 2025, when the rings completely disappear, it unfortunately is going to be too close to the sun, so we won't be able to see it. We will be able to see at opposition, as you can see here, it's a 2025 version down here, a very, very thin aspect of the rings. But for now, if you're interested in looking at the rings, now's the time to do it. So those rings are going to get narrower and narrower just in the next few years. So this is an animation of Saturn at all of its oppositions and how it changes aspect to us as both of us go around the sun. So the rings in context. Okay, so here we have the Earth. It's about the main set of rings, A, B, and C are about 4.5, or actually all the rings are 4.5 Earth diameters. Total, there are 21 Earth diameters, so it's a very, very large structure, but they're extremely thin. They're only about 1 kilometer thick, so that's why the rings disappear when we see them exactly edge on from Earth. They also have names, so I'm going to get to a little bit more detailed picture, but just this is basic. The main rings that we can see are the outer one, the outer thick one is A ring, then the B ring, and a thinner C ring. There are more than those, but that's what we amateur astronomers can see. We can also see the Cassini division, which is kind of a thicker black division between the A and the B ring. And then within the A ring, there's something called the Encke division or Encke gap. And that's because there's a shepherd moon called Pan, which has caused a little empty spot in that ring. This is the only slide I have of the belts. Saturn has belts like Jupiter, but they're not nearly as pronounced in difference in color. They're also thicker. But they're named similarly to Jupiter's belts. So you've got the North Equatorial Belt, North Temperate Zone, North Polar Hood, Equatorial Zone, which is actually quite thick, then South Equatorial, South Temperate, and South Polar Hood. But we don't see a lot of variation, but you definitely do see some when you're looking at Saturn within that yellow and brownish color. So amateur astronomers, here's a better graphic from Cassini, can see the A ring, the very B ring, and the C ring. Here's the big, thick the Cassini division, which is very easy to see. And then the Encke division is this thin black line at the edge of the A ring, almost at the F ring, which is harder to see, but should be possible in a good amateur telescope. And again, that one is caused by the moon Pan, but there's a big difference in their thickness. So the Cassini division is about 3,000 miles wide, 4,700 kilometers, and the Encke division is a puny 325 kilometers across. But these are features you can look at in your telescope. You can also see up to 5 of the brightest moons. This particular picture, and they're always going to be in different positions every time you look. This particular picture adds Mimas, but in my telescope, I don't see Mimas. I see Dione, Titan, Enceladus, Tethys, and Ray in a dark sky in an 8-inch telescope. If I have a bright Houston sky, I sometimes see Titan and a couple others when it gets dark. And if it's a really bad sky, I'll only see Titan, or if it's a very small telescope. So Titan is always the farthest one out and the brightest in your telescope. So if you see something hovering about this kind of distance that looks sort of like a star that's just kind of very, very steady near Saturn, it's likely to be Titan in a telescope. So here's just a little bit more of a graphic of the rings and the relative the distances of the moons from Saturn, how they sit. So you can download an app, or you can use Sky and Telescopes tool. If you're looking at Saturn, you want to identify the moons. There are apps which will tell you in real time which moons are where, and they usually have a way of flipping the picture to match your view in the telescope. So some telescopes turn things upside down, some turn them backwards and upside down. You do want to be sure, or you can flip it in your head, like all those puzzles where you had to flip solids in your head and say what's the same. But be sure you match the distance and the relative positions of the moons to what your app says. So here's a detailed image of the Shepherd moons. So these were discovered more when we sent Voyager up there. There are a lot of tiny little moons we couldn't see, but we now have a much better idea that these gaps in the rings and the distinct rings where they're thicker in some places and thinner in some places are due to resonances with Shepherd moons that are very close to the rings, where they seem to clear out parts of the rings in some places and cause extra density in other spots. So the rings are really made out of debris, mostly ice, some rock, and they range in size from a grain of sand to about the size of a house for the largest particles. And they lie in an incredibly thin plane. So much of what we know about Saturn in detail comes from the flight of Cassini, which has been operating since 2004 and just gathered an enormous amount of close-up photos. You can see in this one, what we're going to talk about later, the hexagonal shape at the pole. And Carolyn Porco was the astronomer, the planetary scientist who headed the Cassini project. So one of the things you can see in your telescope, as well as in the Cassini images, is the shadow of the planet on the rings. I often find that very, very striking to notice in your telescope because it gives Saturn more of a three-dimensional look. So be sure to look for that if it's present. There's also a phenomenon called spokes in the rings, which were first noticed actually from Earth by Stephen O'Mara. He was a columnist for Sky and Telescope magazine, now living in Botswana, famous for his eagle eye vision that he claims is trained. I mean, he also has very good eyesight, but he made a major effort to train his eyes to see an enormous amount of detail. And he started sketching these dark shapes going across the rings instead of with them, and was accused of making them up for many years. Then when Voyager 2 went over there, they actually saw the same phenomenon. So he thinks maybe they're sprites, but what we're hearing now, what I'm seeing the latest theories are that they may be dust suspended above the rings. They may be associated with lightning strikes. But one thing that's interesting is they travel with Saturn's magnetosphere and not at the same rate as the particles in the rings. And the other thing that's interesting is they don't appear during midwinter or midsummer. They are seasonal and appear during the equinoxes. So there's some kind of space weather thing that seems to have to do with this. They disappeared for a while. They showed up again with Cassini. So they are definitely thought to be a real phenomenon. We are seeing them repeatedly with spacecraft flying by them. Saturn also has at least 83 moons. 53 are named now, and then there's countless small moonlets. So Titan is the largest. We'll go over the largest moons. Titan is the largest one. It's the second largest in the solar system, just 2% smaller than Jupiter's largest moon, Ganymede. And it has an atmosphere that's 95% nitrogen. And we did go dive in beyond under that atmosphere with the Huygens mission. And it's thought to have maybe an ocean underneath that. Mimas was known. I remember when the pictures first came out, and it was very striking for the enormous crater relative to its own size. So we think there was a huge impact that almost split it. But this may be one of the largest craters relative to the size of a moon in the solar system. Iapetus is very, very dark on one side and very, very bright on the other side. So we call, by the way, the term for that, for how bright a body is albedo. So we'd say it has high albedo on the white side and very low albedo on the dark side. And I'll also mention that now we have all these satellites going up into space, and we're worried about their brightness showing up and ruining images. One solution to that, which they're trying, is to paint them black. So if we can lower their albedo, it's not a perfect solution. They still have some brightness, but brightness is called albedo. So Enceladus also has geysers. So it has water and vapor geysers and a vast ice ocean. Under an ice ocean. So we think these things are that there's some heat down there. You can have some kind of warmth in the outer planets and moons for the moons, it can be through tidal forces. For the planets, it can actually be because of pressure. So obviously the outer space is extremely cold, but the outer moons can have some warmth underneath. There's also water vapor geysers. These were considered amazing when they were first photographed. So that's something we did not know about until we sent spacecraft to Saturn. And then here's a striking image of Earth from Saturn. So we look back at ourselves, and now we're looking like a star, just like Saturn looks to us. And this is Rhea, one of the larger satellites against Saturn. And here's a storm on Saturn's surface. So occasionally we do get some storms on the surface. Saturn's surface is not seen to change as fast as Jupiter's. But one thing Saturn has is the second highest. It's the second windiest planet. So Uranus is the windiest. So Saturn has winds thought to be close to 500 miles per hour. That's actually faster than Jupiter's winds. And we do occasionally get for a few months some sort of storm or some kind of new feature that shows up on Saturn. This is the kinked F ring. Again, not something that we as amateur astronomers can see, but it's just nice to know it. We think, again, it's probably some kind of interaction between moons and the ring, kind of altering, sort of like a spirograph, altering the way those particles orbit Saturn. And then this is one of those interesting features is the hexagon at the pole. And now the thought is that you've got, just like Jupiter, you have incredible wind shear. You've got winds passing each other in opposite directions. And the thought is this might be a standing wave. So I looked up standing waves, see if I could get a good schematic of how that works. Here it is again, and this beautiful color image from NASA. And here's how a standing wave works. So you've got waves passing in opposite directions, the green and the blue, and then the red represents their sum, so how they operate. And notice that the red sum is not really changing much, it's just sort of oscillating back and forth. So you have waves going opposite directions, creating a third wave or effect that seems much more static. There is an organization called ALPO, the Association of Lunar and Planetary Observers, which if you want to become a serious observer, this is the one to join. And because they have all sorts of details about how to look at the planets, how to make observations that are of scientific value. And one of these days I need to redo a sketch talk. But what I have learned in those talks about sketches is what people do is they'll try to find moments of very good seeing where they can see parts of the planet very clearly and quickly get an idea of that shape. And what you might notice in these sketches is what they do is they enhance contrast. So Saturn may look very low contrast on its surface when you see it in the eyepiece, but you will see differences in color and brightness. When you're sketching for information, what you want to do is try to exaggerate those. So you make the darks darker and the lights lighter. So the same thing here on Mars. If I look in the eyepiece, I might not see these really dark spots as that pronounced. I might see a more even looking brown spots. But if I want to get some information that's useful, I will emphasize that contrast. This one I stole off of Cloudy Nights. It came from a forum, and he calls himself Rutilus. I unfortunately don't know his real name, but he did post this, and I thought this was a great image just to show how people sketch in the eyepiece. And the reason now we have amazing imaging technology, but it was always more difficult to get an image of Saturn than to get a really good sketch. Because when you look, you will have moments of clarity that your eye can see, but because of the exposure of the camera, that clarity doesn't last long enough for it to get those crisp edges. That you get fuzzier pictures than what you see in the eyepiece. And we're now combining images, so that's less of a problem. But still, what you sketch is probably going to be sharper than most people are able to image. And then finally, there's a super Saturn out there. I remember this is one of the first exoplanets discovered, and they know it has all these rings by seeing stars pass in and out, seeing how brightness changes behind those rings. And then I have actually happened to have a painting of, it looks like the Texas Hill Country with a windmill and bluebonnets, and there's a huge Saturn in the sky. But I've always wondered, just as a thought experiment, would it be like to be on a city on a moon around Saturn? It'd be exceptionally beautiful. So for now, we just have to enjoy what the spacecraft can send, and maybe someday we'll have some humans who will get a look. And finally, I'd like to end with this image of Saturn eclipsing the sun. So this is actually a very general talk. I can tell you that on Wikipedia, there's an enormous amount of detail. There is an article about Saturn, but if you want to really know every detail about Saturn's rings, there's a separate article about the rings of Saturn, which will go into quite a bit more detail than we're able to see in a telescope. And I'd like to tell my favorite Saturn story. It was Sadie at the George Observatory. So we had a fantastic Saturn that night. And there was a little 3-year-old girl with blonde curls who was afraid to climb the steps. We had a daub out, and it was just 3 steps. We had a handle, but she was terrified of going up there. It's like, I can't not show her Saturn. So we really pushed her for a while. I kept telling the parents, I said, we have to convince her to see this. She finally made it up there. We spent like 3 or 4 minutes with her. And then she took this really long look. And then when the line continued, every 4th or 5th person was Sadie for about at least 5 times in a row that she kept coming back to the look. So do try to get your little kids to take a look at Saturn. It was well worth the effort. And I don't know what Sadie's doing now. She must be grown up, but Saturn really impressed her once we could convince her it wasn't scary to look through the telescope. So this talk is not too long. Last time I probably made the mistake of combining Jupiter and Saturn into one talk. Chris Morissette will talk about Jupiter next month, and it will only be a very few days after opposition when the October meeting comes around. So you'll only be about a week past opposition. But do be looking at Jupiter. It's getting closer and closer. I think I forgot the exact date. It's September 23rd, I think, or 24th, somewhere in there is its opposition. So enjoy both Saturn and Jupiter at this time and learn what you can about them, and be sure to look at them over a long career as an amateur astronomer, because it's constantly changing. So I'm going to go ahead and stop my share and try to answer any questions if we have them.
Awesome job. Thank you, Debbie, for that great presentation. Can you all hear me okay by chance? Am I off mute? Yeah, okay, I see Bill giving me the okay sign. All right, I didn't have any questions in the chat feature itself, but I know a few people did raise their hands, and I see Blanca has her hand raised right now. Blanca, did you have a question?
Yes, I would like to know why all the moons they are so different. One, even it may have like organic life, and I don't know if they were made from the same, or why it makes them different, because they are kind of on the same environment.
Right. So a lot of it is proximity. I mean, they're going to be ice and rock for the most part. But as far as whether they have anything that's in liquid form, or there's anything like volcanoes like you have on Io near Jupiter, a lot of that has to do with proximity to the planet and tidal forces. So if you have a lot of tidal forces on a moon, or say a large planet pulling on one side, Io is so close to Jupiter. We're talking about Jupiter now, but it's so close that even the pull on its near side is different from the pull on its far side. But it also has a lot of other moons outside of it. So so often the moons are different based on size, and also whether they have a lot of tidal forces on them. So the closer in moons might be have more active surfaces, and farther out moons are more rocky and inactive and more cratered.
Debbie, if I'm not mistaken, one of the reasons why Titan may have a fairly substantial atmosphere is just the pure size of it, right? Being able to have enough.
Yes, it's very large, but I haven't looked up why I was like, today I was like, oh my gosh, I actually don't know why Ganymede doesn't have an atmosphere.
Oh, that's true. Yeah.
So Ganymede's slightly larger, and I don't know what this has to, and Titan's pretty far out. And that's something I need to look up. It's like, oh my gosh, I don't know if I can learn this before this talk. But definitely size has to do. Titan's actually larger than Mercury. Titan and Ganymede are slightly larger than Mercury. So it has the gravity, has enough gravity to hold on to an atmosphere for a while.
Perfect. And before we get to Chris's question, I see your hand up. Gail did have her hand up earlier. Gail, I don't know if you want to come off of mute and ask your question. If you had a question, give you a second or so to come off of mute there. And if not, we can circle back around afterwards. But okay, in the interest of time, I'll ask Chris Morissette to come off of mute and ask his question, our good friend Chris. Hey, Chris, are you there?
Yeah, I'm here. I'd like to go back to retrograde. If I get a lawn chair out on a night in my driveway and watch Saturn throughout the night, I am not going to see it make that curlicue maneuver that you showed us, am I not?
No, you'll see it over many, many months. So Saturn for a while will be heading really kind of to your left, and then it's going to go for several months. It's actually several months long that it goes backwards. And that always happens approaching opposition, through opposition, and then past opposition. It's because we are faster than it. So if you do line of sight to Saturn, it goes backwards for a few months and then it comes back. And then after we get completely around it and we're no longer passing it, then it moves a lot slower than we do, but starts moving slowly in the correct direction. And that was really confusing to the ancients, especially when they thought they thought the Earth was the center of everything. It's like, why are these planets making curlicues? So there's a lot they didn't know, and it was kind of upsetting since everything was supposed to be perfect circles and perfect motions.
So that movement is actually, if I go out at 9 o'clock each night for several weeks or months, that will be the change in position that I'll see.
Right. So right now, Saturn is moving one direction in the constellation Capricornus, and then it's going to reverse direction. in a couple after we get all the way around it. So it'll start to go the other way in the sky. And then it'll go the other way for a long period of time.
Thank you.
Yeah. And it's all just the perspective we have from Earth, right? So Saturn.
Right. It's just a line of sight from something faster passing up something slower.
That's it, exactly. All right. Who else has any questions they want to come off of mute and ask of Debbie?
Hey, Joe, it's Chris Shoemate. I have a question. It's not on Saturn, but it's on light pollution, if I could ask that.
Yes.
I think you have a captive audience with Debbie, so absolutely.
Yes, well, please.
I've learned a lot from Debbie just in the last year. I've been a novice on a number of these talks. So early this week, I was pleased to see a story. I don't recall which local TV station it was. It was, I believe, the Audubon Society, but it was covered, and they ran the story several times about efforts here in Houston to get commercial buildings downtown to turn off lights during about a 6 to 8 week migration period. And it seemed to be getting a lot of traction. The City Hall was involved in some way. Mayor's office, there was somebody appointed from the mayor's staff to get involved. Are you aware of that? Are we?
Yes. And it took me actually a year to even get the Audubon to respond so I could give them a light pollution talk. The Audubon Society in Kansas City was actually the main, not the amateur astronomers, it was Audubon that got Kansas City to change its streetlight plans. And I worked with an Audubon member and sent her all sorts of information. It took 10 months. They were hearing all the arguments we heard in Houston. But every time they heard an argument from my work in Houston, I had exactly the reference she needed to counteract the argument. So they are going to use a much dimmer, warmer streetlight system. With birds, we really need, first of all, they have a migratory period. So it's most egregious when our lights are on during that period. There's a spring migration, a fall migration. And I think Houston's the second deadliest city after Chicago. We have several large cities that are on the migratory routes. That's Chicago, Dallas, and Houston are the three largest, and Kansas City is also one. And they also, sometimes they concentrate more on interior lighting. So they're pretty good about getting the tall buildings to turn off their interior lights, because that's one aspect, is that the birds slam into the windows, and that can happen on a shorter building too. So interior light is a problem for them. But as far as, I seriously doubt we turn off enough light for us not to attract them to the city through sky glow. So the birds also kind of zero in on sky glow. And then they, I'm hoping, I know we're doing better. There are certain, buildings that used to have lots of dead birds around them. Like there was a story about one in 2019 in Galveston, had hundreds of dead birds around them in the morning, and then they got that one to turn off its lights. But Houston has such a serious problem. I think even that doesn't work for the major problem we have all year round. So the mayor and all the city council are highly aware. I've been working at this since before our streetlights were put in. And the new city council, we have several city council members who are very sympathetic. Those would include Sally Alcorn, David Robinson, and Martha Castick Tatum is very sympathetic. What I don't know is if we have enough city council. What we need is a lighting ordinance. There's a chance, I would say, everybody, please write your city council person in the mayor's office to lobby for a lighting ordinance. We have an opportunity now because they're writing ordinances now, but most of our lighting ordinances in Houston are too light and not too light. So they're getting a tad better. There's a new one that they want all night bars and convenience stores to have. I think it's too much light, a fair amount of light on every inch of their property, but at least they have something that says you can't point it at a residence. It doesn't say you can't point it down the street and blind somebody, just at a residence. There's nothing about color. There's not an upper limit on how much light. So we have no good lighting ordinances in Houston. And the problem with that is that you have people buy bad lighting, and then they have people complaining about light they just put in. So that's happening right now. Someone just wrote us at Beltway, near Beltway 8 and I-10, there is a Home 2 Suites that just did their parking lot lighting, and they are right next to some townhomes. They're 3 stories, and the back of the parking lot that lights all 3 stories windows. It's like literally feet from their windows. And they've been working at it for months trying to get rid of it. So the best we do, I found out from the Texas IDA, is that the Texas Supreme Court does define under nuisance, they define bright light. But we don't have a law in Houston that says you can't point light at somebody, except for that new one on the convenience store. So the message is to use warm light. I just saw my 3rd business using good lighting. It was an Auto Savvy at Fondren and Bel Air. I passed by there all the time coming home from my parents. I was like, what's that warm glow? And this was very, very simple. They had simply taken their old metal halide bulbs, which are similar to the old high pressure sodium bulb you screw in, and they were corncob shaped warm LED bulbs that were not too bright. It was just right. I've only seen 3 businesses do that. I'm seeing a couple more use warm light pointed downward that's still very bright. And that includes a Honda dealership near Beltway 8 and 59 on the south side, and a Caesar's, a Little Caesar's pizza place. So that's starting. But I've seen 5 businesses use warm LED light and only 3 of them using it subdued. So we have a long way to go. And without an ordinance, we have no way to educate people before they put in bad light. So I really think that when we have a horrible city, that the lights out programs are helpful, but a drop in the bucket. And we need overall to have a less extremely brightly lit, wasteful city. And please write. They need to hear from a lot of people that we need a lighting ordinance. Pittsburgh has one for all city lighting. That's going to include all of their street lighting, city building lighting, and park lighting. That will all be warm and subdued. So they will be demonstrating good lighting.
And we need that ordinance. There's no doubt about it.
What's that?
So we need that ordinance. There's no doubt about it.
Oh, yeah. We can't do it without the ordinance. And the other thing I'm working on is trying to educate the police. I know it's doable because I have educated police officers individually, but we need the police saying the same thing, because as soon as people think the environmentalists are telling you to do differently from what they think the people in charge of their security are telling them to do. And I've heard police officers say, use bright lighting, the brighter the better. The only downside is you need blackout shades. I turned that police officer around after giving a talk at the Museum Park super neighborhood. And I've turned another one around showing them my lamp. This is my lamp here. I can point light at them and I can turn it down, and I have figures underneath and behind. I have a website, softlighthouston.com, which is very convincing. But I don't think it's going to get fixed worldwide until we get the police on our side. And the IDA has done very little to get the police on board. So it's constantly, we're telling people one thing and they think the police are telling them something different. And the people who sell them lighting are happy to sell them 5 times more light than they need. By the way, there's a little hope. There's a street and area lighting conference coming up in Dallas, and I'm starting to see good topics like is my health and lighting, and my favorite is it time for LED to LED retrofits? So I think now the lighting is so bad that now the lighting people who sell lighting are going to want to sell the better lighting and not wait 20 years. So maybe this will get fixed. I was worried it's going to be 20 years. Yeah. Maybe it'll get fixed in 5 years, because now they're going to want to sell us all the new improved lighting.
Well, thanks again for your leadership on this very important issue. You taught me a lot in a short amount of time. So thanks again. And thanks again for your talk tonight on Saturn. Very informative.
Thanks. I'm glad I didn't talk too long about Saturn.
Well, Debbie, the other thing I'll mention is, I live off the Washington Avenue corridor here, and because of enough complaints from residents about the bars and clubs, the city just recently passed a noise ordinance around here that required permitting and things like that. So we never thought that would ever come to pass, and eventually it did. So it just,
yeah, the awareness is going up. We even have city council members. What I'm doing now is photographing. If you notice an auto pedestrian site, we are showing there's a lot of glare from businesses at fatal auto pedestrian accident sites. And that's what I'm going to use to try to convince the police. Art Acevedo actually had people call me, accident investigators. He took it seriously. The very high profile 3 valet accident where 3 valets were run over, that was a speeder, but one of our members lived in the townhomes there, and they had been complaining about a light at the valet, at the valet station that was pointed straight down the street. She said, even though he was speeding, he said, there's no one who lives here who thinks that guy could see the 3 valets, and you could hear him trying to avoid them at the last minute in the police video. So that light's still there. One I saw that blinds me still at Bel Air and Atwell is still there. That was another site of a fatal accident. And my advocate friend in Kansas City she told me she went to a site near her. She said exactly what you said, a bright business light right behind the bus stop. And then I found not only the accident, but that there was a whole article in Kansas City that was one of their most dangerous intersections for pedestrians. So I'm hoping that'll get traction with the police.
Good deal. All right. Any other questions for Debbie?
Yeah, Debbie, this is Bill Spizzeri. You mentioned we should write. Who exactly should we write to? I know it depends on where you live, but can you give us some guidance?
Oh, okay. So if you're in Houston, if you're in unincorporated, you can also write Harris County. You can write the engineering office in Harris County. For Houston, go to Houston with a tx.gov/council. And from there, you can find for each council person a map of their territory and their office number and everything else. So if you don't know who your council member is, there's also 5 council members at large. Mike Knox is a former policeman. He actually saw our lamp demonstration, and it took him 30 seconds to convince them. He said, "Are you telling me we've been lied to?" I proved to him with the lamp that you can see a lot better with subdued warm light than with bright, high glare white light. So it also saves money, but Houston makes money selling energy. I think that's one of the reasons it's been extremely difficult here.
Well, Debbie, speaking of saving money, and sometimes it's deaf ears, but I just drove from downtown out to where I live in Katy. And so I took the West Park Tollway, and all of the way during the day today, both directions, so lunchtime and then rush hour evening, all the street lights on West Park were on all day. And of course, it wasn't dark.
Yeah, so I've noticed sometimes that happens when they're turning all those from high pressure sodium. They used to be a beautiful shielded high pressure sodium, one of the few we had. They're turning them all to white LED. And sometimes when they're new, there can be some kind of malfunctioning with them. Closer in, I'm not noticing that during the day. So hopefully that won't last forever. But sometimes I'm not sure why they do that. I've seen that happen with new lights before. But you might let them know. Anyway, there's, everybody who's changed to warmer lights also turns them down. So there's just no reason for us to be blasting. There is something which seems like few people know about, but I was urged to get the new guidelines. And I think this is one of the best points to make. In chapter 2 that the Illuminating Engineering Society puts out for guidance for street lighting, they almost say they made a mistake. They said, well, there's two curves for spectral sensitivity. What color light appears brightest to your eyes? Well, it turns out that when you're fully dark adapted, like us amateur astronomers, and we've been out there for 30 minutes, then the blue or white light appears brightest to our eyes. But when there's enough light for you to see color and you're using the cones, not just the rods, it's actually the warmer light. It's actually somewhere in the yellow-green, but a little bit like some of the Shell stations, but a warmer, more golden light is the very brightest, not too different from the old high-pressure sodium. And the blue-white is way down the curve. I need to get that onto I use it in my talks. I think I better get it onto my website. So what we're doing is it's why you see this really bright white light in the parking lots, and somehow the parking lots just don't look that bright unless they're incredibly bright. So we're actually using a color that our eyes don't see very well and blasting it, and that short wavelength is scattering all over the place, and it's hugely damaging for everything, health, it's damaging to our health because it's suppressing melatonin. I have located a doctor at, I was researching again pancreatic cancer and light, found someone at UT Health Science Center. She's willing to talk to the city. She found, this is correlation, not causation. She found 55% higher thyroid cancer in brightest areas and 27% higher pancreatic cancer. We've already seen dramatically higher breast, prostate, and colorectal cancer, where melatonin is being suppressed by exterior light. So there's nothing good about it, except for those who sell light, unfortunately.
So right to whoever will listen.
Yeah, right. We're getting some traction. It's not just me now. Museum Park Super Neighborhood has talked to them now. But now's the time they're considering ordinances. And of course, they have this this climate action plan. It's got everything in there, even nationally. It's got everything in there except for solving light pollution, which is the easiest thing to solve.
Yeah. All right. Well, Debbie, thank you so much for the wonderful presentation and, of course, the passionate plea to get people to act on these lighting issues. And I'm sure we'll be hearing more about that in future presentations. So thank you very much. And thank you all for joining us tonight. I hope you can see my screen here. But I just wanted to share some information about tomorrow's meeting. We will be online only, starting at 7 p.m. tomorrow through Zoom. So if you haven't had a chance to register for that meeting yet, please go to our website, astronomyhouston.org, and get that link to register. We'll also live stream it through Facebook if that's how you prefer to watch it. And it's going to be a fantastic talk. We have Dr. Taft Armendraw with the McDonald Observatory, who's going to be joining us to talk about the Giant Magellan Telescope. In this era of giant telescopes and space telescopes and things like this, it should be a wonderful presentation. We're also going to have lots of announcements about exciting new events and things that are happening at our observatory and social events that we're going to have out and about throughout Houston. So please join us if you can tomorrow at 7 p.m. If you're on any of the social media platforms that we have listed there, please give us a follow. And if you have any questions you want to ask of myself, Debbie, or anybody in leadership at the Houston Astronomical Society, you can always send us an email at info@astronomyhouston.org. So with that, I'd like to, again, thank you all for joining us, and we hope to see you tomorrow night. Take care.